you look at all of these and you say, how did all of these happen? They didn't happen because we just wished them to happen. They happened because there is a serious effort made by many great people and many great talents that I'm sure a good number of them are with us today.
But I want to take this opportunity to recognize your fantastic efforts. And we just finished our board meeting, and I'm quote unquote, really quote unquote, what was said is that the biggest achievement of the Gulf Downstream Association is the formation and the active engagement of the technical committee.
Hello and welcome to GDA Conversations, brought to you by Gulf Downstream Association. This is an ongoing series in which we talk to the leaders and subject matter experts from the downstream industry on relevant topics of wide interest. My name is Raj Hajaria, Technical Manager with GDA, and my guest today is Kevin McQuillan, who is the Senior Consultant from Solomon Associates. He is a professional mechanical engineer with 35 years of industry experience. He is also a part-time lecturer with the Robert Gordon University in Aberdeen. Kevin is also a subject matter expert in the Operational Excellence Technical Committee of GDA. Today, we are also joined by some of our subject matter experts from some technical committees to interact with Kevin after his presentation. So let's start today's conversation with Kevin. Hello, Kevin. Good morning. How are you?
Good morning. I'm doing well. Thank you. How are you?
Very good. Very good. Kevin, I believe today you have chosen a topic, staying true to your reliability journey, which implies that some of us might not be true to our reliability journey. And you will show us how, especially in the current situation of COVID-19. So good luck to you, Kevin, and over to you.
I'd like to start by thanking Gulf Downstream Association for this opportunity. And I would also like to thank the audience for joining in with this conversation. The title of my presentation is Staying True to Your Reliability Journey. I picked this topic mainly because Solomon has a lot of data that shows reliability is key to world-class manufacturing performance. And I'm going to share some of the learnings with you today using data taken from our reliability and maintenance benchmark study. I've divided the presentation into 5 parts. I'll say a little bit about maintenance strategy and the importance of maintenance strategy, and then I'll talk specifically about reliability and maintenance benchmarking and how it can help in organizations' ambition to improve. Then on section 3, I'm going to start digging into some of the detail. And in section 4, I'll highlight some of the key messages, and particularly with a focus on the current situation. Then hopefully there'll be some time for discussion. So to start with, let's talk a little bit about maintenance strategy. One of the things that Solomon finds when we work with clients is we get to learn a lot about who are the good performers and who are the not so good performers. And one of the things we find is that good performance is closely associated with a robust maintenance strategy. And I'd like to say a few words about what that implies. Firstly, it's important to recognize that maintenance is actually a cost to a manufacturing organization, but it delivers value by ensuring that the production units and plants are available to make the product for sale. So maintenance is a cost, but it does deliver value. In terms of maintenance cost, there is a very visible cost in the money that you spend maintaining the assets, and that visible cost is likely to attract a lot of attention in the current situation. However, there is also a less visible cost, and that less visible cost comes in two main parts: the value of production associated directly with lack of maintenance when the production unit is broken down and not available to operate, and also the value of lost production associated directly with maintenance itself in the form of production unit overhauls and turnaround. This less visible cost is often less clearly measured, and many organizations can forget about it, particularly in times when there's pressure to cut costs. So a maintenance strategy, and in this context, I'm going to use ISO 13306 as a reference. This is a document that talks about maintenance terminology. A maintenance strategy is the management method used in order to achieve the maintenance objectives. So straight away, it implies that we need to have some objectives for our maintenance work, and those objectives are in the form of targets assigned to and accepted by the maintenance organization. And already you might be starting to think, well, okay, that's fine, but where do those targets come from? Typically, the maintenance strategy is divided into two components. On the left-hand side, maintenance effectiveness, which is the methods that are used to determine the appropriate types of maintenance for each asset. And on the right-hand side, maintenance efficiency is everything that you do in order to ensure that the work you do within the organization is delivered safely and cost-effectively. And we'll talk more about effectiveness and efficiency later on. The other aspect to the maintenance strategy, and this is very important, is that it needs to be supported by metrics and targets. Those metrics and targets exist at the high level in the form of maintenance cost and potentially in the form of mechanical availability, and also at a lower level in terms of things like types of maintenance, individual asset reliability, the ability of the organization to plan, efficiency, backlogs, and so on. And the important point is that these lower level working metrics all feed one way or another to one of the higher level targets set by the organization. If you're measuring something at a working level that does not feed your overall objectives, then you might reasonably wonder why it is that you're measuring it. So in terms of optimization, we might think, so how would we know when our maintenance strategy is optimized? And the thesis that Solomon used is that the maintenance strategy may be considered to be optimum when the total cost of maintenance is at a sustainable minimum. And I'll illustrate this in a chart with imaginary data. I'm looking with time at the money spent by the organization, and I'm going to add together the money spent on maintenance, and in that money I will annualize the turnarounds, and then I'm going to add to that the value of lost production associated with maintenance overhauls and turnarounds, and finally the value of lost production associated with production unit breakdown. And you can see that my imaginary organization is improving over time, but it is a long time. And one of the things Solomon knows from our data is that performance change, whether improvement or deterioration, does take considerable time. So you might wonder for this particular organization, not only how is it tracking the impact of the actions that it's taking on performance, but ultimately, what target should it set? How does it know when it is achieving a true sustainable minimization of its total cost of maintenance? And this question mark is a key, and it's where benchmarking comes in to help. So I'll say a little bit about reliability and maintenance benchmarking. And the first thing I'm going to do is show you a chart. And the chart is actually similar in nature to the chart I showed previously. And what I'm showing here on the right-hand side is the total cost of maintenance for the client's production unit, both the value of lost production and the money spent on maintenance. And I'm now comparing that with the performance of similar production units within the industry. And I'm dividing those units into 4 quartiles of performance. Each quartile contains 25% of the units that we have in the study, and the bars show the average performance of the units within the quartile. The RAM effectiveness index is Solomon's definition of the total cost of maintenance, and we divide that by the plant replacement value in order to give a fair comparison for assets that are of different size. So what is this graph telling us? Well, firstly, benchmarking is helping to understand what is possible. From the client's perspective, he now sees quite clearly what his ultimate target could be based on the performance of the industry. So the client can now understand his current performance, he can understand what is possible, and he can establish high-level targets based upon his ambition level. In addition, a good benchmark provides further information because it allows us to understand the characteristics of the leading performers. And I'll illustrate this later. It allows us to dig into the detail of the things that they do that deliver the performance they achieve. This allows the client to set action plans based on achievements within the industry, and it also allows the client to establish working metrics and targets for those working metrics, secure in the knowledge that if he drives performance on the working metrics, ultimately that performance will reflect in the high-level metrics set by the organization. So this chart allows us to look at performance change over time, and it's taking the same data but showing it on an XY axis with maintenance cost on the X-axis and mechanical availability on the Y-axis. Clients would like to be in the grey box with high mechanical availability at low cost. Now, Solomon has a lot of clients that repeat their participation in our studies, and the data gives us some interesting insight. The first thing it shows us is that performance improvement with time is possible, but it takes commitment, it takes competence, and it takes time, typically 2 to 5 years, including at least one turnaround to deliver sustainable and measurable improvement in performance. The second lesson is that sustainable performance improvement is best achieved by investing in reliability. And in this context, we explain it in 2 aspects: reliability of the assets by targeted spending on unreliable assets, and reliability of the people by investment in leadership and culture. We find that the highest performing organizations view people reliability in the same way as they view safety. Reliability is everybody's responsibility, and everything can be done reliably or unreliably. The final lesson from this slide is that cost cutting, and here we get to a consideration relevant to today's situation, cost cutting can lead to a short-term reduction in costs, but we have no data that shows cost cutting leading to eventual sustainable overall performance improvement. So if you look at the solid bar on the chart, we have a lot of data from clients that follows that sustainable path. Reliability improves as you invest in it, and that ultimately leads to a reduction in spend. we have no data that shows the dotted line. Typically, when clients cut costs, the data eventually shows that their reliability decreases and then their costs go back up again, creating a cycle of decline. So let's dig into a little bit more detail. And now I'm going to drill down into the RAM study data, and I'm going to look separately at effectiveness and efficiency. Firstly, to define effectiveness in this context, it is the extent to which the work undertaken has the desired impact on the reliability of the asset. It's about doing the right work, making the right choices, and delivering your work to the required specification. The desired impact should be improving the reliability of the asset, restoring the asset to its required function if the asset is broken down, controlling the potential risk of future failure, or in the case of inspection, and this is a key point, providing information that can be used to inform future decision making. Too much inspection is easy to do, but it does not necessarily provide information that is useful to the organization. So I'm going to show you two charts that dig into effectiveness in more detail. The first one shows non-turnaround downtime of the production unit divided into short overhauls, equipment failures, and rate reduction. And I'm showing this by quartiles of overall reliability and maintenance performance. And you can see quite clearly that the best performers achieve better online reliability. And we'll look in a little bit more detail about how they achieve that. Their production units are typically running reliably between turnarounds. And interestingly, although not shown on this chart, they achieve this by taking smaller, faster, and less frequent turnarounds than their poorer performing peers. And this is actually a major differentiating achievement. For those of you who operate plants, you might like to think about how you measure the success of your turnarounds. Most of our clients measure it in terms of cost, duration, and potentially safety. But very few clients look at the effectiveness of the turnaround in the ambition to deliver online reliable operation between events. The best performers do, and they achieve that, and this creates a major differentiation between them and their competition. The second set of charts looks in detail at maintenance work hours. On the left-hand side, I'm showing maintenance work hours by quartiles of performance, broken down into corrective maintenance in blue and proactive maintenance in yellow. And in this context, proactive maintenance is any combination of preventive, predictive, reliability improvement, and end-of-life replacement. The chart on the right-hand side shows by quartiles of performance how their maintenance breaks down into emergency corrective, non-emergency corrective, and proactive. And the implications of this chart are quite significant, but we need to think a little bit to understand what they are. Firstly, better performers work fewer hours in both corrective and proactive work. If we think first about corrective work, it's clear why this would be the case, because better performers have better asset reliability, and corrective maintenance is a direct function of the reliability of the assets. Therefore, better performers have lower corrective maintenance work hours. But when we come to proactive maintenance, this is perhaps a little bit of a surprise, that better performers also work less work hours in proactive maintenance. This is because, against my previous slide, they're able to truly optimize the work that they do and ensure that each and every proactive maintenance task that they undertake adds value in terms of protecting the reliability of the assets. Poorer performers actually do more proactive work than their better performing peers, but a lot of it adds relatively little value. They keep doing the things they've always done without necessarily understanding why. And we'll come back to that point later. Now to talk a little bit about efficiency. Efficiency is the extent to which the work undertaken is delivered safely and at the optimum cost. Are we doing the work the right way? And this should involve consideration of the use of operators to do simple maintenance tasks, particularly in the current situation where the operators perhaps are the only people on a daily basis at the site. Creating the right balance between contractors and client resources, using contractors cleverly where it is cost effective to do so, ensuring that all of the technicians are technically competent to do the work that you ask them to do, and adhering closely to best practices and maintenance processes. And again, to show a little bit of data to illustrate this point, on the left-hand side, I'm showing the same chart as I showed previously, where I'm breaking maintenance work down into emergency, non-emergency, and proactive. And on the right-hand side, again by quartiles of performance, I'm illustrating the ability of organizations to plan their work, schedule their work, and then complete their work as per their schedule. And again, in both charts, the quartiles are quartiles of overall performance. The first observation is that better performers do significantly less work in an emergency mode. Now, we know from our data that when you do a job as an emergency, it can be typically 6 to 9 times more expensive than the same work if it is done in a planned way. And in addition, work done as an emergency is typically less safe and is typically not delivered to the required specification. So organizational discipline is important. If a job needs to be done, the better performers take the time to do it in an organized and planned way. Better performers are therefore less reactive. They take the time to plan, to schedule, and to deliver work in an organized way according to high standards and the schedule they've established. Poorer performers actually get good at solving crises. Better performers do not have crises within their organization. And I'll leave you to think about what type of organization you currently work for and what type of organization you would like to work for. So just some key messages from all of this. Firstly, make sure your maintenance strategy is current. Make sure it addresses mechanical availability and maintenance cost. Make sure it contains clear actions, and make sure it is supported by targets and metrics. Think long term. Solomon knows from our data that performance improvement with time is entirely possible, but performance does not change over 3 to 6 months. Typically, organizations need 2 to 5 years to see sustainable and measurable performance in their high-level objectives. Avoid short-term arbitrary cost-cutting. There is no data that shows that this is an effective long-term strategy. Having said that, now is a good time to review the proactive maintenance work you do to ensure that all of the tasks you choose to do truly add value in the aim of protecting and improving reliability. And the data says that for most organizations, there is scope to do less proactive work without impacting the reliability and availability of your assets. There's a big difference between arbitrary cost cutting and a considered and structured review of the work you undertake. The final message from me, and then we'll turn it over to questions, is please keep in mind that your turnarounds are key contributors to your overall RAM performance. If you choose to defer your turnaround in the current situation, please be very careful that you understand the risks involved in deferring the time-critical tasks that the turnaround contains. So that's a quick canter through Solomon's reliability and maintenance study, some of the key lessons that it teaches us, and I'd be happy to try to answer any questions.
Thank you very much, Kevin, for this insightful presentation and some of your suggestions and advices. I was, while watching your comparison between effectiveness and efficiency, I came across an analogy that if you are trying to climb a staircase, then that is how fast and how efficiently you can do that is efficiency. But whether the ladder is inclined on the right wall, that is the effectiveness. So you choose the right work and you work rightly. So this is a very nice comparison I found from your presentation. Also, in the current situation where people are tempted to cut cost, especially in the present situation, also where people are not able to undertake turnaround which are planned and they are delaying, they are postponing. Do you have any message to them? Do you have any suggestion to them?
So, I mean, firstly, to say effectiveness and efficiency are both important, but if you're doing the wrong work or a badly chosen task, no matter how efficient you are, you're not gaining value. So that's one important message. In terms of turnarounds, a turnaround is a large accumulation of maintenance tasks. And if you analyze the work list for the turnaround, you'll find that a percentage of those tasks are time critical, but an equal percentage or potentially a greater percentage are not time critical. So what we would encourage clients to do in considering deferring the turnaround is to look very carefully at the work list and be sure that if you're deferring a time-critical task, you understand the associated risks. And the more time-critical tasks you have, the more those risks compound to a point where, in the limit, deferring the turnaround is an unacceptable risk to the organization. So if you're going to defer the turnaround, have a hard look at the work list.
Thank you, Kevin. I think that's well said. Risk management is the key for any deferment, and also to find a workaround for those critical tasks which probably need immediate attention. With that, I will open the view for everyone. Welcome to all our subject matter experts from the Operational Excellence and Plant Reliability Committees. And please just identify yourself, and please go ahead with your question by unmuting your audio and video, please.
The question, I think one of the slides reflected that Solomon suggests to go for small TNI instead than large ones. Could you please elaborate more on this and see the actual, really, we want to see the effectiveness of those, because sometimes, I mean, we want really to consider both the cost of having those small ones against the big ones, and then probably the reliability in both cases. So if you can elaborate on this.
Yeah, so thank you, Haifa. So the first thing to say is, if you look at a typical refining or petrochemical plant and you annualize the cost of the turnaround, it is typically about 30% of the total maintenance cost. What Solomon does when we do our studies is we annualize turnarounds both in the cost of the event and the downtime that it causes. So the cost is the event cost divided by the interval, and the downtime is the event downtime divided by the interval. Now, what we see is that better performing organizations use the combination of interval and duration to get lower annualized impacts than the poorer performers. So what they're doing is limiting, first of all, limit the turnaround to the work that can only be done in turnaround. Don't do work in the turnaround that can be done online. And secondly, make sure that the turnaround scope is the jobs that have to be done, not the jobs that are nice to do. And what we see as a result of all of that is that when we annualize the impact of turnarounds on performance, companies in quartile 1, not only do they have better online reliability, their turnarounds also are lower cost and lower annualized downtime.
Yeah, but do you recommend to have a number of units, TNI at the same time, or that is not really recommended? So some refineries.
Well, it depends on the site, Haifa. I mean, certainly if the units are interdependent, it's better to take them all down at the same time. If you have independent units and one can be shut down without impacting the others, then there's an option to take that unit separately from the site. What we find is that most petrochemical and refining sites are mainly production units that are interdependent. So there's a drive to take them all down at the same time.
Okay, thank you.
Yes, Raj, I have a question.
Yes, I'm not from Setor.
Yes,
Please go
good
ahead.
morning. Sure.
Yeah.
Good morning, everyone. Thanks, Kevin, for the great presentation. I just have a small question for the availability, the performance of the availability. How do you relate it to the maintenance strategy and the operation best practice? So if you have, let's say, a perfect maintenance strategy and you don't have that much of a good, I would say, a best practices of the refinery operations, how do you see the impact on availability? I hope I'm clear.
So, yeah, it's an interesting point. What we do in our RAM study, we look at mechanical availability. So we look at downtime associated with the condition of the asset. If the asset is broken, or if you choose to maintain it, that is downtime. If you have downtime because of maloperation or fouling, that is not considered impacted by the maintenance strategy. So in the RAM study, it is not accounted for. That said, maloperation of the plant can lead to failure or underperformance of the assets. So what we would encourage clients to do, you might have a perfect maintenance strategy, but your operators might not care about the condition of the equipment and therefore might operate it outside of the normal parameters. What we encourage clients to do is use root cause analysis to understand the root cause of asset-related downtime and then to take corrective action as appropriate. So for instance, if your rotating equipment is failing because of maloperation, you address the maloperation. If it's failing because of inappropriate mechanical seal design, you address the seal design.
Yes. as you know, the equipment after years became aged, and the cost of maintenance will become more. How can we measure the performance of the turnaround or maintenance by the age of the units and the refinery as a whole, especially when we need to benchmark the performance of different refineries in the area? Thank you.
Well, that again is a very interesting question, and thank you for answering it. We do, when we benchmark using the RAM study, we do ask about the age of the production units. Interestingly, we do not see a structural relationship between age and total maintenance cost. What we find is that some of the better performers, they do two things as their assets age. They invest where appropriate in end-of-life replacement, and they also learn to focus their preventive maintenance on the areas where maintenance is required and avoid spending money in areas where the assets are in good condition. It's a little bit like you and I as we get older. We can either choose to smoke and be unhealthy, or we can choose to use the gym and stay healthy. What we find in our studies is that aging of petrochemical assets is something that the better performers learn to manage well, and it does not necessarily lead to their performance deteriorating.
Okay, thank you.
Thank you.
Thank you, Mr. Ahmad, for this question. So, Kevin, what you are saying is with age, we have to better look after ourselves.
Yeah.
Absolutely, and
Right.
I will say that some of the very best performers in our study are running assets that are over 30 to 40 years old. It's about the organization's ability to learn and take care of itself.
Great. I thought age is only a number. Any other
too.
question? Thank you. Any other question from other subject matter experts?
Sorry, Mr. Raj, but I want to ask
Sure.
again the question.
Sure, go ahead.
Are there any correlation between the cost and the age of the equipment? As the equipment will face the corrosion and chemical attack, the cost will be higher. If we want to measure the performance, can we put a formula to consider that the performance is good or not by taking into account the age of the equipment?
So the answer is in two parts. On average, yes, there is a correlation that older assets are more expensive to maintain on average. In the best performing organizations, that correlation does not apply because they are better at optimizing the work they do. And it is something that we can look into in detail for individual clients, but the important message is that your performance need not deteriorate with age if you truly optimize the work that you do. On average, you're right, but it's a manageable process.
Okay, thank you.
Related to age. Sorry, I have a question.
Sure, Haifa, please go ahead.
I mean, age of a chemical plant is not really similar to human age, because usually human plants, they get really revamped, renovated, updated, upgraded. You would hardly really see any plant without really upgrade within 10 years. So at least I'm talking from our experience here. So from Solomon, how do you see really the average age for first quartile or second quartile, third or fourth? Is it really normally almost the same, or do you see that the first quartile average age is that much, or that many number of years?
Right. So it's the same, really, the same answer to the previous question, Haifa. If I look at the 4 quartiles, the average age increases from quartile to quartile. So the average age of plants in Q4 is higher than the average age of plants in Q1. But some of the best performing plants are, some of the oldest plants are in Q1. So it is on average, performance deteriorates with age, but it is not necessarily the case for all assets. And I'll give you one observation. If you look at the ISO standard definitions of maintenance, it includes a category called reliability improvement. So what we see is companies that manage the age of their assets well invest in a targeted way out of their maintenance budgets to improve reliability. And here I'm talking about things like bad actors, where you have a pump that fails regularly. Very often, if you invest in a different mechanical seal design, that failure can be removed so that the investment pays back in reduced future maintenance spend. The best performers eliminate defects. The poorest performers tolerate defects.
Okay, thank you.
Well said, Kevin. We move to Mahmoud Alawi from Chevron. Mahmoud, you have your question.
Yeah, Kevin, thanks for the explanations. I mean, OEM recommended maintenance times is something quite big in the industry for turbines, for for compressors, for machinery, and those usually the ones that drive the cost up, because if you basically go by them, then they dictate your turnarounds cycle and cost, and usually they are replacement type, and the equipment are of an expensive type. So how do you think these can be managed, in a better way?
Well, a great question, and I agree with your point. And oftentimes, it's interesting to think about why the OEM recommends the intervals that he does. The only thing I can really say is that high-performing clients typically start by taking the recommendation of the OEM, but they learn from the maintenance they do about the condition of the equipment at the point where it is maintained. So if you undertake maintenance on equipment, but that equipment is in perfectly good condition, a high-performing organization would then challenge the basis of the chosen maintenance. And what we do see is in high-performing organizations, the intervals between turnarounds are perhaps longer than in some of the poorer performers. So I think that the message is to challenge your OEMs to make sure that in the view of your own technical experts, the recommendations of the OEMs are soundly based.
I have a follow-up question to that, Kevin. When an OEM recommended strategy is changed, of course, if it is changed with their agreement, that's okay. But if it is changed without their consent, does it impact on the long-term arrangement of providing service? Does it violate any of those?
Well, I think it depends on the OEM, but most units are operating well beyond the normal warranty period. And I would entirely agree with you, Raj, that the best way to approach this is in consultation with the OEM, not in contradiction with the OEM.
Sure.
But what I would encourage is that consultation. It's better not simply to accept and keep doing the same thing over and over again, but challenge the OEM to justify the basis of his recommendations.
Good. Mohammed Al Muali, Chief Operating Officer of GCC Lab. Do you have any question, Mohammed?
Yes, I have a comments on the relation between the total ownership cost of an asset and the age of the asset. From our observation in Saudi Electricity Company at that time when I was working for them, that there was no rigid straight line relation between the total ownership cost of an asset with the total with the age of the asset, because of the high competition between the OEMs to come up with a compacted design, optimum design, less cost design. We noticed that the new generation of the equipment, the number of failures becoming more, which forced the company to change even the maintenance regime, which introduced another cost. If you can elaborate on this.
Thank you, Mohammed. Yes, Kevin.
Yeah, I mean, it is a complex relationship, and I would certainly agree that there is no, when we benchmark, we look for structural relationships that are typically straight line. We do not see a structural relationship between maintenance and reliability and asset age. And what I would say is the situation is very different for different types of assets. So if you look at a refinery where you've got an asset with significant furnace equipment, then that equipment needs earlier investment than on an asset without furnaces. So it's production unit dependent, and I would certainly agree that in the electricity industry and the refining industry, those relationships between maintenance cost and age might differ. But the primary message is, at least based on our data, the better performing organizations are able to mitigate the impact of plant age on their spend.
Kevin, I have a question. We are running currently a survey in which we are asking our audience a question: what is the financial value of a good reliability and maintenance strategy over a plant life of 20 years, expressed in terms of percentage of the plant value? What is your take on that percentage for the good performer?
So it's an interesting question, and it's one that a lot of company chief financial officers might reasonably ask. How good is my maintenance and reliability, and what impact is it having on my bottom line? Now, if we look at the difference between the quartile 1 and quartile 4 performers, we see that typically the difference is about 8% of the replacement value of the asset per year. So with a typical plant life of 20 years, the difference between the best and the worst is the value of another plant. So it is a very reliability and maintenance performance is a very significant financial differentiator between the best and the worst in the industry. The best save the value of the plant compared to the worst.
So a worst performer would have spent a complete plant value in maintaining an asset poorly.
More than he needs to, yes.
More than he needs to.
He'd have spent the value of the plant more than he needed to.
And any other question from any of our subject matter experts? I don't see any hand, which means their questions and quest has been satisfied with your presentation and answers, Kevin. And let me take this opportunity, first of all, to thank our subject matter experts for joining, taking some time out of this busy schedule in the current crisis to share their wisdom, also to interact with Kevin, to extract some valuable insight of this amazing journey of reliability, in which we hope we will remain true. We will remain true to this journey. That's the message Kevin wants to take us. Kevin, do you have any last thoughts?
No, only to thank everybody. I enjoyed the discussion, and I think investigating the impact of plant age is something that Solomon might reasonably start to look into our data to investigate further. So thank you for those questions, and I appreciate your involvement.
Thank you very much, Kevin. Thank you, everyone, and thank you, our viewers. This series is continuously going on. We are connecting with more leaders and more subject matter experts. And if you want to catch up on our previous conversations, there will be a link below this video post on the YouTube, or you can go to our website and watch our previous very engaging and interesting conversations with the industry leaders and subject matter experts. And once again, thank you very much for giving your time and patience, and I hope this session has benefited you. God bless. All the best. Thank you.